run through. So let's go. There we go. We'll remove the high-tech piece of card that was covering the camera, and then hopefully my face should appear. If not, we'll just have to switch it. Doesn't appear to be wanting to do that. Come on, technology, you can do this. So, video capture, UVC camera, FaceTime. Let's go old school. There we go. You should be able to see me now, and that should be coming through live and clear shortly. Okay, so let's begin the class. For those of you that are in here, it's a 6 o'clock start. We've managed to do that. You could have a doodle while you waited. Clearly, that's not happened. That's not time to do that now. But I'd like to ask the people that are on the Pear Deck to answer a couple of questions for us. So thank you for joining. Looking forward to the next 45 minutes or so. So let's see where you are at right now. So students that are on the Pear Deck, you need to go to the bottom right hand side. I believe there's an answer question option. If you hit that answer question option, and I can show the responses on the screen. One person says, I love mole problems. One person says, to tell me enough to pass. Or 6 people say, tell me enough to pass. I'll never do moles again. And thankfully, not one person has said that horrid, yuck, horrible, get me out of here. Thank you very much for those positive responses. Okay, next question. Don't worry, we'll start with some real slides shortly if you're not in the Pear Deck. How big is a mole? Just how big is a mole? You have 3 options on screen. Take your votes now, please. A is a mole of marbles would cover the earth up to a depth of 3 miles. B is a mole of $10 notes would stretch from the sun to Pluto and back 7.5 million times. And C is a mole of toilet roll, that's very topical and very COVID specific, would wrap around the earth 657,400 times. Whoever mailing is, you needed to join at the beginning on the Pear Deck joining instructions. Don't worry, we'll be on to some normal slides shortly. So actually, in terms of the response, we've got 12 of 17. I'll give you another 10 seconds or so to answer these questions. If you're just joining a bit late, it's joinpd.com, and the joining code is in the top right-hand side, JCHJIR. Oh, thank you. I'm glad someone's got a sense of humour this Thursday evening. So we've got 14 of 17 responses. It seems like the mole of marbles to a depth of 3 miles is a very unpopular option. It seems like a mole of $10 bills would stretch from the sun to Pluto with 7.5 million times. And a mole of toilet roll is perhaps the most popular. Perhaps that's the most topical that's been in the news recently. And in fact, they are all true. Every one of those is true. Okay. The next one we're going to look at, we're going to have a look at the periodic table. Okay, so we've got the big numbers and the small numbers. I say the big number and the small number because the periodic table makers, the printers of these things, like to swap them around just for a laugh to keep students guessing for no other reason. Okay, so the big number is the atomic mass and the small number is the atomic number. So we all know the small number is the number of protons, which equals the number of electrons for a neutral atom. Okay. Now on this periodic table, ptable.com, this is linked on your Pear Deck, we get 3 decimal places. For IGCSE, I think it goes to 1 decimal place. I think it's for chlorine, which is 35.5. But remember to use the big number when we are talking about moles. Okay, so we have one formula for moles, don't we? Moles is mass over Mr. Okay, I'm not sure my technology is working. Could someone give me a yes if you can see the slide saying formula 1 of 2 with the moles is mass over Mr. triangle with a fairy mole in the top. Can you all see that, please? Someone give me a yes. Thank you, Ivy. Thank you so much. So I find that moles are yesence. Thank you, Millie. Moles are these little fairy creatures that hang around in the mud, and they burrow through the mud and they dig up bits of grass. And you can see it's actually got a snout, a mouth, I'm not sure what you call it, a digging implement on the front. This is like a JCB of moles. And there's just one lovely formula. So little n is little m over big M. A mole is a unit, haven't you heard? 6.02 by the 23rd. We're going to come to that. Loving your approach. Thank you, Nick. So here are some worked examples. I was going to do a flash animation and have them all pop up as I talked through them. But then I was in Pear Deck and I was like, it ain't going to play. It doesn't like animation in Pear Deck, so hands up, I'm a newbie at this. So, how many moles is 6 grams of carbon? Well, we can flick to our periodic table. We'll see that the atomic mass is 12. It's 12 grams, but moles is the mass over the mister. Go chemistry, there's a little n, a little m, and a big M. And it's just really unhelpful because it all sounds like the same letter. I wish they would change those letters to make them sound different because they are different things. Moles and moles. Mailing is just a spelling thing. Moles is shorthand, but really you're just losing an E. I don't think there's any need for that. Excuse me. So little n is moles. Little n is moles. Little m is mass. And big M is the molecular mass, or the sum of the atomic masses added together in a compound. So I start easy. 6 grams of carbon. Moles is mass over mister. The mass is given in the question, which is 6g. From the periodic table, 1 mole has a mass of 12g. So it's simply 6 over 12 is 0.5 moles. So 6 grams of carbon is half a mole of carbon. Okay, slightly more challenging, sodium hydroxide, NaOH. If we look in the periodic table, Na has an atomic mass of 23, sodium is 23, oxygen is 16, and hydrogen is 1. So 23 add 16.
Hello, good afternoon.
Add 1.
Welcome to chemistry.
Is
just checking this is
40. I was seeing there's a massive delay between my phone. Is 40. So that 1 mole has a mass of 40 grams. So we're given 20 grams. So 20 over 40 is again 0.5 moles. And a really good rule of thumb in IGCSE chemistry, particularly coordinated science, where I assume most of you are from AIS, welcome everybody, it tends to be whole numbers. They tend not to give, I don't know, 1.2 by 10 to the minus 4. That tends not to come up. It doesn't mean it can't, but it does tend to be nice nice numbers. Sam, thank you. Will they ask us a question in kilograms? Yes, they can. And there was one a couple of years ago, Ollie, which is I'm being remembered by, is they asked something about ammonia was so like 6 million grams of ammonia were formed, or 6,000 kilograms were formed of ammonia. You had to change the 6,000 kilograms into 6 million grams, then divide it by the molecular mass. So they can use big numbers just to check your unit conversion. Does that answer your question, Ollie? I hope so. So moles, if we've got 20 grams of sodium hydroxide, the mass given is 20, divided by the sum of the atomic masses, sodium 23, oxygen 16, hydrogen 1. 20 over 40 is 0.5. Happy days. How many moles is 6 grams of H2O? Hydrogen has an atomic mass of 1, so there's 2 times 1, which is 2. Oxygen has an atomic mass of 16, so 2 plus 16 is 18, so 6 over 18 is 1/3 of a mole. So 6 grams of water is 1/3 of a mole of water. All looking good. What if we swap it around? What about how many grams? How many grams is 0.2 moles of CH3COOH? Prize for guessing, if you know what CH3COOH is, it's ethanoic acid. Now mass is moles times mister. Remember our equation? mass is moles times Mr. So we've got 0.2 moles, but we don't know Mr. So Mr is going to be, well, there are 2 carbons, so that's 2 times 12. I've done them singly so you can see reading along the chain. So there's 1 carbon, which is 12. 3 hydrogens is 3 times 1. The atomic mass of hydrogen is 1. Another 12 for the next carbon. 2 times 16 for the 2 oxygens, plus another 1, which equals 60. Clearly I missed the 1 out at the end, but it's in the sum. It is 60. So 0.2 of 60 is 12 grams. So 0.2 moles of CH3COOH is 12 grams. Sarah, what's Mr? Kawa, thank you for your question. Mr is capital M, little r, and it means the molecular or the atomic mass. And I know that students sometimes get confused with that because it's also written as sum of atomic masses. If you are looking at one atom, like, I don't know, lithium, that has an atomic mass of 7. If you're looking at sodium chloride, NaCl, you have to add the Na, which is 23, to the Cl, which is 35.5, to give 58.5. So the Mr depends on whether you're looking at an element or a compound or a molecule, and you have to abide by the numbers of each element in the molecule or the element or the compound. I hope that answers your question. Another one, how many grams is 0.4 moles of ammonia? There's a random G there. How many grams is 0.4 moles of ammonia? Well, nitrogen is 14. Hydrogen is 1. So 14 plus 3 times 1 is 17. BODMAS, do your multiplication first. 3 plus 14 is 17. 0.4 of 17, which is Mr for NH3, if that answers your question, Kara, is 6.8 grams. So what am I doing? I'm looking at the question. The question, first of all, gives me a mass or a moles, and gives me the formula. If in the question it gives you a mass or a moles and a formula, immediately you're using N is little m over big M. In other words, moles is mass over Mr. I find often students get these questions incorrect because they use the wrong formula. We'll see that in the question shortly. It would be unusual for the IGCSE to ask you the exemplars at the bottom, but for completion, I've put them in. So what's the MR if 2 moles of a mass has a mass of 40 G? So now I want the MR, which is this one here, it's going to be mass divided by moles. So the mass is 40, the moles is 2. So it's 20 grams per mole. It doesn't tell you what the compound, the molecule is. It just tells you it has a molecular mass of 20 grams per mole. It will not get any more difficult. The mass over N, here the mass is 7.2 G, and the moles is 0.5. So the MR is mass over moles, which is 7.2 over 0.5, which is 14.4 G. I will link this presentation underneath the video at the end of this presentation if you want to review and go through these sums in your own time. So this is equation 1. In chemistry, there are only 2 equations and 2 bits of information that you need to know. In physics, there's about 2 pages of formulae. In chemistry, just 2 equations, 2 bits of information. Okay. Hot tip number 1. I've already alluded to this, but hot tip number 1 would be underline the keywords in the question. This question from a few years ago was badly answered. Why? Because they did that thing. Who asked that question? Mailing asked that question. Do they ever do funny things with units? Yes, they do, and they have here. So a chemical company, it's always those chemical companies, produces 3.4 by 10 to the minus 9 G of ammonia. Thank you, I know where the button is on my calculator. Here's the ammonia synthesis. You will all have done this in class, I am sure. N2 plus 3H2 makes 2NH3. Bonus points for remembering the catalyst is iron. Complete steps 1 to 4. I've only left steps 1 to 2 because many students got 1 to 2 incorrect and then they didn't have a Scooby-Doo what they were doing in 3 and 4. It tells me a number of items in the question. It tells me the formula of ammonia, NH3. It tells me the mass produced, 3.4 times 10 to the power of 9. It also tells me the molar volume of a gas is 24 decimeters cubed at room temperature and pressure. It's unlikely for them to tell me things that I don't need to use, so I'm going to have to use these at some points. The IGCSE is really actually quite, kind, and it kind of holds your hand through the calculation, so it's stepwise for you to build up to the final answer. Step 1, show the relative molecular mass of ammonia is 17. Well, the relative molecular mass is the same as the number of grams in 1 mole of the compound. Okay, so I've got ammonia, 1 nitrogen, 14, 3 hydrogens, 3 times 1 is 17. So the answer is 17, the relative molecular mass. Just remember that all these masses are relative to the isotope carbon-12. It's 1/12 the mass of an atom of the isotope carbon-12. So there are no units, it's just relative to carbon, so it's 17. So it's just adding up. And you can guess why many students got this incorrect. Maybe you can, maybe you can't. I'll tell you why. Students got this incorrect because they were using this number 2 in the balanced equation. They were working out 14 plus 3 times 1 is 17, then timesing it by 2 and giving 34 as the answer. I'm wondering why can I not get 17? I mean, it even gave you the answer in the question. And this is a fundamental understanding which many students don't get. So let's have a quick look. Nitrogen is N2, hydrogen is H2, ammonia is NH3. Ammonia is always just 1 nitrogen and 3 hydrogens. But I hear you say there's a 2 there. Well, yes, the 2 that's bookkeeping, that's accountancy, because I had 1 molecule of nitrogen here, N2, with 2 nitrogen atoms in it. So I can't just lose my nitrogen, I can't just gain a hydrogen. It all has to be accounted for. It's not Harry Potter, it's science, as I would say. Okay, let's have a look. Mailing, you're being hilarious today. Hi sir, will the questions be set out similar to this tomorrow? The ones that you can see on the screen, yes, this is from a past paper. So yes, I stole it from there. Will we get follow-through marks if we get step 1 wrong and use that number later on, provided we continue to use the correct method? Yes, Rid. Is that Taylor? Yes, you would. Error carried forward would normally apply. However, I would say, even though many students got this incorrect, I would have a word with yourself and think, it tells me it's 17, why am I writing 34? But many students didn't do that, so it's an honest mistake to make. Thank you, Taylor. Next, calculate the number of moles. Okay, some students don't know, they had a brain breakdown, whatever it was. 17 times it by 24, because that's the mass of 1 mole, and that's the molar volume, so 17 times 24 is whatever it is, and that was just completely incorrect. Moles is the mass. The mass is given in the question. It's here, 3.4 by 10 to the power of 9. Divided by the sum of the atomic masses. You've already worked out the sum of the atomic masses here, which is 17. So mass divided by molecular mass is moles, which in this case worked out beautifully. And normally it does, as I said. 2 times 10 to the power of 8 was the number of moles of ammonia produced. I didn't do the next step, but I'm sure you can work out that given the number of moles of ammonia, which is 2 times 10 to the power of 8, if it asks you what's the volume of gas at room temperature and pressure, all you need to do is times the number of moles by 24. That's why it's given in the question, because it's saying the molar volume of a gas is 24 decimeters cubed, so 1 mole has a volume of 24 decimeters cubed. So 2 times 10 to the power of 8 moles has 2 times 10 to the power of 8 times 24 decimeters cubed at room temperature and pressure. So this was from 2019. Nice question. Probably around half kids, 60% of kids got it correct. 40% did some strange things within this question. So that's a real life question using moles is mass over mister. Worked examples from all 3 different ways you can approach that equation. And just don't forget, moles is mass over mister. And if it cheers you up, draw the fairy mole at the top. Okay. I said there were 2 equations and 2 pieces of information you need to know. Let's start with the 2 pieces of information that you need to know, as well as our fairy cuddly mole there. 6.02 by 10 to the 23 is the number of things in 1 mole. It's an awkward number. We know it's an awkward number. It's a massive number. Remember going back to that earlier slide, a depth of 3 miles of marbles on planet Earth. That's how many 1 mole is. Why is 1 mole so big? It's so big because atoms are so tiny and we like to count them because we're chemists. The other thing you need to know, and they often give you this in the question, as they did in the previous question here, is that 1 mole of any gas, doesn't matter if it's nitrogen, carbon dioxide, oxygen, neon, mustard gas, doesn't matter. 1 mole will always have a volume of 24 decimeters cubed. So half a mole of any gas will have a volume of 12 decimeters cubed. A quarter of a mole of any gas will have a volume of 6 decimeters cubed, and so on. So everything is a multiple of the 24, or it's factorized. I have dinner, but I'm going to save it for later. I'm really glad that you're enjoying this mole presentation. Ah, there it is. Are you excited? Look, Formula 1, moles is mass over mister. Formula 2, whoomp, there it is. Concentration is moles divided by volume. C is N over V, is the other way that you'll see this written. Concentration is measured in number of moles. These are the same moles that we're working out here, exactly the same moles, per cubic decimeter. Now deci means 10, so that's a cube of sides 10 centimeters by 10 centimeters by 10 centimeters, hence it's 10 cubed, and 10 times 10 times 10 is 1,000, we all know that. So 1 decimeter cubed is 1,000 centimeters cubed, which happens to be a litre, but we don't use litres because we're chemists, we use decimeters cubed. So if I can work out my moles, which I can, I did that in the previous exercise, and I know what a decimeter cubed is, it's 1,000 centimeters cubed, I should be able to work out a question from the IGCSE, working out any of these 3 in the little triangle that we have here. So how about this top one? How many grams? What's the mass? Same question. How many grams are in 500 centimeters cubed? 500 centimeters cubed. That's, well, 500 is half of 1,000, so that's 0.5 decimeters cubed. I'm thinking in my head already. Of a 0.25 mole per decimeter cubed solution of sodium chloride. How do students get this wrong? They use the wrong formula. They use moles is mass over mister, because they see moles, this is C 0.25. They see sodium chloride, NaCl, Na is 23, chlorine is 35.5, you can see it in step 1. The big M, the molecular mass of sodium chloride, is 58.5 G, so surely 0.25, a quarter of 58.5, is the number of grams. No, it is not. If you are given the units moles per decimeter cubed, which is a concentration term, you must be using C is N over V, not N is M over big M. And the confusion about those 2 formulae and when to use them, I would say, is well over half of incorrect responses on mole calculations on IGCSE papers. 3 steps to each, as you can see. Step 1, what's the mass of 1 mole? Sodium, as I've said, is 23. Chlorine is 35.5, so the mass of 1 mole is 58.5 G. But in the question, it's telling me I've got 0.25 moles per decimeter cubed. So in every 1,000 cm cubed, there's a quarter of a mole. So what's the mass of a quarter of a mole? Well, mass is moles times Mr. There's my moles, 0.25. There's my Mr. Worked out in step 1. So a quarter of 58.5 is 14.6. This is the mass. This is the mass. Let's keep the thread. This is the mass of sodium chloride in 1 decimeter cubed of a 0.25 mole per decimeter cubed solution of sodium chloride. But we don't have 1,000 cm cubed. We have half that. We have 500 cm cubed. So we have half of the mass. So half of 14.6 is 7.3. What we've done, if we've times the mass of the 0.25 moles by 500 over 1,000, because we've changed the cm cubed into decimeters cubed. Basically, those good with numbers, we've just halved it, right? Because it's half a decimeter cubed. 500 cm cubed is half of 1,000 cm cubed. So what part of a decimeter cubed is 500 cm cubed? It can't get much more difficult than the second example. And again, I will emphasize where students get this incorrect quite a bit. How many grams are in a 250 cm cubed of a 0.1 mole per decimeter cubed solution of calcium nitrate? Now you're all here, you're all listening. Thank you all for being here. In this molecule, there are how many calcium atoms? There are 1. How many nitrogen atoms? 2. How many oxygen atoms? Expand the bracket. 6. Not 3, not 5, 6. And I know that in maths you do this with your eyes shut, and you've been doing this for years. It seems that you come into chemistry and forget how to expand a bracket, and even a simple term like this. Many students get it wrong. So just please ensure you can read formulae. That's why I put this example in here. So again, what's the mass of 1 mole? We've got 1 calcium, which is 40. 2 nitrogens, nitrogen is 14, so 2 times 14 is 28. And 6 times 16 is 96, which equals 164 grams. Now, you don't have to remember the atomic masses in the periodic table. We give you a periodic table. We're generous like that. I'm just so old now that I've taught it so many times, I just remember too many of them. It's a 0.1 mole per decimeter cubed solution. So if 1 mole is 164, squeezy lemon, absolutely, bang on. 1,000 cm cubed is 1 dm cubed. The concentration is 0.1 moles per decimeter cubed. 1 mole has a mass of 164 grams. So 0.1 moles will have a mass of, well, 1/10 of that, 0.1 times 164, which is 16.4 G. Again, this is in 1,000 cm cubed, and we've actually only got 250 cm cubed, so it's a quarter of that, which is 4.1 grams. So that's how many grams are in 250 cm cubed of a 0.1 mole per decimeter cubed solution of calcium nitrate. Is 1,000 cm cubed is 1 litre, is 1 decimeter cubed? Yes, absolutely. If you learn nothing else today, learn that much. Okay. Is this the 3-step question? Yes, it is. Josh. So this is the ground, this is kind of the foundation stuff I wanted to really get you to appreciate. Read the question. If it says moles per decimeter cubed, then you're using N equals C times V, C equals N over V. If it just gives you a mass and the formula, you're using moles is mass over Mr. Normally in class I would now say capiche. Hopefully, yes. Read the question. Twice, maybe 3 times. So here is a question that's a bit more challenging. So this is a titration question. I can't remember what year this is from. I dragged it within the last 3 years anyway. The equation for this reaction is 2 sodium hydroxides, 2 NaOH, plus H2SO4, makes 1 mole of Na2SO4 and 2 moles of water. This is as complicated as it gets at IGCSE because it's not a 1-to-1 ratio. Calculate the concentration of the sodium hydroxide. Give your answer to 3 sig figs. Okay. The information was on the other piece of paper, which didn't have room to screenshot and put into the presentation. I've just put in bold black writing on the top right hand side. So 25.00 cm cubed of NaOH and 18.20 cm cubed of H2SO4 of concentration 0.1 mol per decimeter cubed. Those are the figures for the neutralization. Neutralization is where H plus and OH minus make H2O. This is H plus from H2SO4, OH minus from NaOH, making our H2O here. Students often look at this and don't know where to begin. And I have marked many papers. This is often left blank because they just do not know where to begin. And I would always say the best advice I can give you is just begin. Okay, just start. Do I know the concentration of sodium hydroxide? No, it wants me to calculate the concentration of sodium hydroxide. Do I know the concentration of sulfuric acid? Yes, I do. It's 0.1 moles per decimeter cubed. I know the volume of sulfuric acid. So I've got V and I've got C. If I've got V and C, I'm not using N is M over M. I'm using N equals C times V. Okay, again I'm saying C moles per decimeter cubed, straight to C is N over V. C is N over concentration is moles divided by volume. Make moles the subject of that equation. So moles of sulfuric acid is C times V, which is 0.1 in the question, times 18.2. Now don't forget that's in centimeters cubed. And my concentration is in moles per decimeter cubed. So I have to change my 18.2 cm cubed into decimeters cubed. There's two ways I can do that. I can just do 18.2 times 10 to the minus 3. Prakash, yes, C is concentration. 18.20 by 10 to the minus 3, or 18.2 divided by 1,000. Same. We need to put that volume there into decimeters cubed to give us moles, because we can't times moles per decimeter cubed by centimeters cubed. That will not give us moles. We want moles. So first trick or first step, first thing you need to remember, always convert your cm cubed in a titration to dm cubed by dividing by 1,000. I've got my moles of sulfuric, 1.82 by 10 to the minus 3. So that's 1.82 by 10 to the minus 3 of this one here. Yes, V is volume in decimeters cubed. Looking at the equation, 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So if I had 1 mole of sodium hydroxide, I would only need half a mole of sulfuric acid. If I had 1,000,000 moles of sodium hydroxide, I would need 500,000 moles of sulfuric acid. Yes, Nick, we always convert to decimeters cubed. This 2-to-1 ratio, this is the second stumbling block, apart from just beginning, where students tend to fall down. I've worked out my moles of sulfuric acid. That's here. I've got 1.82 times 10 to the power of minus 3. It's a 2-to-1 ratio. I need twice as much sodium hydroxide, according to my equation. That's why I balanced it. I need twice as much sodium hydroxide. So I need 2 times the moles of sodium hydroxide, so the mole of sulfuric acid, sorry. So 2 times the 1.82 by 10 to the minus 3 is 3.6 by 10 to the minus 3. So I've got 1.82 by 10 to the minus 3 sulfuric acid, 3.6 by 10 to the minus 3 NaOH. If you want to ask any questions that go through this, this is sort of the top sort of A star stuff right now. Please type them into the chat. 1.82 by 10 to the minus 3 sulfuric, so therefore 3.6 by 10 to the minus 3 of sodium hydroxide. I'm kind of getting, 3 marks now. I think I'm about 3 marks. So how do I get the last mark? Well, that 3.6 by 10 to the minus 3, I worked out by calculating the moles of sulfuric Factorising for the sodium hydroxide is a 2-to-1 ratio, so times 2. But they're in 25 cm cubed of sodium hydroxide, in 25 cm cubed. And I want it in decimeters cubed. Who was saying that? Nick. Yes. So now I'm not going to say I've got 3.6 by 10 to the minus 3 per 25 cm cubed concentration of sodium hydroxide. It's not incorrect, but we don't talk in terms of 25 cm cubed portions. We talk in moles per decimeters cubed. How do we get from 25 to 1,000? Well, there's two ways. There's always a couple of ways you can do this. First way, we'll just times it by 1,000 divided by 25. Or you will see the shortcut on many websites, times by 40. If there are 40 25s and 1,000. And then the answer comes out as 0.14 moles per decimeter cubed. Okay, so this answer here came from, first of all, starting where I could begin, volume concentration to give me moles, 2-to-1 ratio, twice as much, that's the moles of the unknown, which was in 25 cm cubed, which I need to factorise to scale up to the 1,000, which gives me 0.14 moles per decimeter cubed for the unknown concentration of the sodium hydroxide. I will say that this was off the triple award paper. I'll let that little secret out the bag now. So for a single award, higher chemistry. And on your coordinated science, it would say, part A, calculate the moles of sulfuric acid or of H2SO4, Bush, put that in. It then does say, what is the ratio of sodium hydroxide to sulfuric acid? How many moles of sodium hydroxide is that? Okay, it does, as I said, it holds your hand through the question. This is a triple paper where they don't hold your hand, you just have to run with it. So, and as someone said earlier, if you get this first bit incorrect for whatever reason, and all the rest of your ratio is correct, your doubling is correct, your scaling up to 1,000 cm cubed is correct, then you get 3 out of 4, which is 75%, which is good in anybody's book. Nick, yes, yours is very hand-holdy. Yes. And then at the very top end, this is the very top end, is on limiting reactants. And this floors students quite a lot. So I always start with cheese sandwiches, because I like cheese sandwiches. So we've got 2 slices of cheese and 8, I call those bread cakes. I call those bread, I don't know what do you call those things in the middle? Rolls? Baps? Barms? I don't know. Anyway, you're going to make a cheese sandwich. You've only got enough bread rolls to make 2 sandwiches. The cheese sandwich. Yes, the cheese sandwich analogy, I love it. I love cheese and onion. Anyway, that's not what this is about. There's enough to make 2 cheese sandwiches. You will still have 6 rolls of bread left over. Just bread, Josh, thank you. 6 rolls of bread left over. And that's the concept of, thanks, Arjo. That's the concept of limiting and excess reagents. So here we have, from the good old trusty BBC, the BBC, how much aluminium chloride is formed when 2.7 G of aluminium are reacted with 9.125 G of HCl. It's just like being in class, look at that. What mass of aluminium is formed when 2.7 G of aluminium are reacted with 9.125 G of HCl? They've repeated themselves. The equation is given. I love BBC bite size, nothing wrong with that, apart from a bit of repetition there. And cheese is fantastic, IVS. So there's 2 lots of aluminium, 6 lots of hydrochloric acid. It gives me 2 to 6, it's a 1-to-3 ratio. This is good, giving me 2 and 3. Where do I start? Where I can begin. 2.7 of aluminium. Well, aluminium has atomic mass of 27. 2.7 over 27 is 0.1. Aha! Very nice, very obvious, lovely GCSE question. Nice round numbers. I've got 0.1 moles of aluminium. How many moles of hydrochloric acid? Well, it tells me I've got 9.125 G. Hydrogen has a mass of 1. Chlorine is 35.5. So the molecular mass of HCl is 36.5. So the mass given is 9.125 over 36.5. So I've got 0.25 moles. So I've got more moles of HCl and less moles of aluminium, but the ratio is 2 to 6. So there's 1 aluminium to 3 HCl. And this is the bit where people fall down. So 0.1 moles of aluminium only would need 0.3 moles of HCl. But there are only 0.25. Let me do that again. 0.1 moles of aluminium would need 3 times as much, it's 2 to 6, would need 0.3 moles of HCl. But we've calculated there's only 0.25. So that means that it is limiting. So the HCl is the limiting reactant. That means this will determine the mass of the aluminium chloride and of the hydrogen that I will get. So if I've got 0.25 moles of HCl, I'm going to get 6 to 2. I'm going to get 1/3 of that, so 0.25 over 3 moles of aluminium chloride. And we're going to get half as much moles of hydrogen. So within there's moles, there's ratio, and then there's multiplying out for the moles that you've deduced by the atomic mass. And that is the top level questions. Okay. So, limiting reactants. Have a look at that in your time. I've linked 1, 2, 3, 4, 5, 6. I'm sure you know most of them. Okay, there's some lovely worked questions and answers at the top. BBC, you know it. There's a workbook with examples. YouTube with Hazel. Brilliant channel, brilliant. And limiting reactants to practice. There's no magic wand to learning these. It's about practice. Yes. Do you have 0.25 mole or do you have 6 by 0.25 moles of HCl? So you just, was this the one that, Lockie, is this the one that you're talking about? You got 0.25 moles of HCl. Yes, you do. No, you do not. No, you do not. Okay, you're not. This is the moles of HCl. This is that point I was making. Thank you so much for asking that, Lockie. That was the point that I was making at the beginning of this presentation. This number here, this number is bookkeeping. That's accounting that I've got the same number of atoms on the left and the same number of atoms on the right. This just tells me the moles of HCl, the molecule HCl, nothing else. Okay, there's not 6 lots of them, it's just of the HCl. Squeeze a lemon, yes, you will have to balance equations. Yes, you will. And that's not the point of this video, but a very quick reminder, always leave the one that's on its own, the uncombined element, until last. Okay? Yeah, good stuff. So here are a number of websites for you to practice with, but I want you to get a good night's sleep as well. Okay? So if you're still in the pair deck, can you have a look and see how have we done? Do you love moles a little bit more, a little bit less? Which is your option? Please check. Right, guys, I make that, I don't think that's working, it doesn't matter. I make that 6:44, so I wanted 45 minutes on 1 minute short. Does anybody have any questions on what we have covered this evening? I can't tell you if there's a lot of moles on the mock, Josh. If you remember, N is M over M, C is N over V, 24 and 6.02 by 10 to the 23. Take your time, take a breath, make sure you're answering using the correct equation. I think you'll do absolutely fine. You're talking gibberish now. I have no idea what you're saying. Okay. Right, guys, I'm going to sign off now then. If you've got any questions, please pop them in the email. I will link the slides. The video will take about 10 minutes to process before it goes on YouTube. As soon as it's on my channel, I will link the slides underneath the video. So it'll be up by 7 PM. How's that for customer service? Good stuff. Okay, guys, thanks very much for coming along. If you're not subscribed yet, please subscribe, and you'll be there for the next update. So thank you very much for your participation. Hope you found that useful, and of course, best of luck tomorrow. Have some good food, have some good sleep, and smash it out the park tomorrow, guys. I'm sure you'll be fine.